Hello, sorry. So the last part of today, let's do this. Okay. So yeah, I was telling you to solve this question, but let's do this together. So a micrometer screw gauge is used to measure the thickness of a plastic board. When the jaws are closed without the plastic board in between, the micrometer reading is shown. So this is actually, the first picture is actually given for the zero error, okay? So let's look at the horizontal line and we can see that the zero is below and that is positive zero error, okay? And this one aligns with 3, right? So it's positive 0.03 millimeters. That is the zero error.
Yeah.
Okay, and now let's look at the main reading. So firstly, you can see that this is 11, this is 12, this is 13, and it is just slightly beyond 13, right? Beyond 13.5 almost.
Yeah.
Okay, so 13.5 plus, now we have to see what does it align with. It aligns with 46, 47, 48, 49, right? This is 49. 49 means 0.49 millimeters. Okay.
Oh, I have a question. Like, how do we know that the numbers are going up? Because it says zero on top of it. So, how do I know that the numbers are decreasing or increasing?
Okay. Good question. Now you have to look at the circular scale. Okay. So you can see that here is 45 and here is 0. And from here the scale starts again. That means এটা নিচের গুলো তো 40 sorry 50 sorry এখানে 50 and নিচেরটা হচ্ছে 40, right? নিচের যে
Yeah.
মার্কটা. So this needs to be 46, 47, 48, 49 and then finally 50. And then you can say it starts from 1, 2, 3, 4 again. Okay. এভাবে. In this case, now if you're trying to determine যে zero error আছে কিনা তখন একটু confusing হয়ে যায় because zeroটা যদি উপরে থাকে I told you to count it downwards, otherwise always count it upwards. Okay, for example এখানে this is 46, 47, 48, 49, 50, এখান থেকে 1, 2, 3, okay, and then 4, 5, 6, 7, 8, 9, 10, like that. Just the only confusion that you might get is when you're dealing with negative zero error. Okay.
Yeah.
All right, so yeah, so this one was 13.5 and then it aligns with 49, so 0.49. You simply add these two numbers and what do we get?
About 13.99.
Exactly, so 13.99 millimeters. Okay. Remember, I think table দেখাইছিলাম যে আমাদের micrometer screw gauge precision হচ্ছে 0.001 centimeters, right?
Yeah.
So in other words, I think 0.01 millimeters. Yeah. Okay. I'm just going to check something, whether my answer is correct or not, because I actually have the answer. Yeah, okay. Great. Oh, okay. Yeah, I made a mistake. This is only the reading of the diameter of the pipe. This is not our final reading. Okay. Sorry, this is not the diameter. This is the thickness of a plastic board. So now the final reading, that is the actual thickness is going to be 13.99 minus 0.03 millimeters. So that gives us, I think, 13.96 millimeters. Okay, that is our answer. Now, what if you had negative zero error? If you had negative zero error, again, এখানে আমি লিখতাম minus, and then everything else would have been the same, except এখানে এসে আমাদের plus হইতো. Why? Because minus minus is plus, and then it wouldn't have been 13.96 anymore. It would be what? 14.02. Okay.
Yeah.
All right. Okay. I think it's clear. Now let's watch a video so that I to clear hoy jinishta. Yeah. Maybe he has a video.
Hi, where can I get a cab?
タクシーを得ることができますか？
はい、そこにタクシー乗り場あります。
Hi, I'm Bob Welds, and this is how to read a metric micrometer.
Okay.
A micrometer is used to take very precise measurements. There are different kinds of micrometers: inside micrometers, outside, depth micrometers, inch micrometers. Just look them up on Wikipedia. But here I have a metric one. This one measures to the nearest 0.01 millimeters. It says so right here. As you turn the knurls, the measuring parts open up. These are called the spindle and the anvil. The spindle moves, the anvil does not. Now to get down to the business of reading this thing, let's take a close look at what's called the barrel scale. I'll have Sparky, my dog, help me out. He's a pointer. You read the barrel scale by looking at the edge of the part that turns. This part's called the thimble. You begin by looking at these marks. You'll notice there are two sets of marks and a line. The marks above the line are millimeters. The marks below the line are half millimeters. Let's stop here a minute and be sure you're with me. What do you think the barrel scale is showing right now? Hit the pause button and think about it. If you said 12 millimeters, you were right. If you didn't, well, there's more to life than being right all the time. Well, let's take a closer look. See, 10, 10 and a half, 11, 11 and a half, 12. Here, let's try another one. Pause the video and think about this one. Do you see it reads 14 millimeters? Good, let's move on. Let's try another one. Now this one's trickier. Pause it for a minute and see if you can figure out what the reading is. Did you say 11 and a half millimeters? See how there's a half mark showing? That counts as a half millimeter. Great. You've got the barrel scale down. Remember that we said this mic would measure down to the nearest 1/100th of a millimeter? Well, here's what that would look like on the barrel. They don't really make marks this small because no one would be able to see them to read them. Obviously, there has to be a better way. Remember that each mark on the barrel is equal to 1/2 millimeter. Another way to think of a half is by saying 0.5. Another way is by saying 0.50 or 0.50. Now, let's put 50 marks on the thimble. As we turn it, the thimble can count from 1 to 50 for us. That means that each mark on the thimble is equal to 0.01 millimeters. Now let's put all this together and try to figure out what this micrometer is reading. First, the barrel scale, 10, 11, 12. So it's 12 millimeters plus something. The something comes from the thimble scale. Let's zoom in. 0.30, 0.31, 0.32, 0.33. So the reading is 12.33 millimeters. Now here's one for you to try. Now it's trickier. Notice the half mark is showing on the barrel scale. Let's see if you can figure out what to do with that. Did you get 11.72? If so, you're really getting this. If not, you might have missed the half millimeter mark. Let me show you. Okay, first look at the barrel. 10, 10 and a half, 11, 11 and a half. Now, write that down. Now, look at the thimble. 0.20, 0.21, 0.22. Now write that down. Now add them together and you get 11.72 millimeters. Okay, there's just one more small concept and we'll be done. What if one of the marks is just barely showing? Do you count it? Is it ready to be used? Here is the trick. Don't look at the mark to find out whether the mark is showing or not. Look at the thimble. You need to know if a new mark is starting or if an old mark is ending. In this example, look at how big the number on the thimble is. It's showing about 0.47 millimeters. That's a big number for the thimble. Remember, the scale only goes up to 49. Since the scale is nearing the end, it's ending, and so you don't count a mark that's barely showing. The trick is to find which side of the zero you're working on. If you're not yet to zero, it's not yet a mark. Okay, I've moved the micrometer just a little bit. Now the mark is ready to be counted because the thimble scale is starting. You see that the numbers on the thimble are small because the zero just passed by. This means that the mark is ready to be counted. Okay, so that's pretty much it. There are some micrometers that can measure even more accurately than this. They have a thing called a vernier scale on them. I can show you how to read those another time if you want. Just let me know. But for now, this should get you started. Thanks for watching. I'm Bob Welds, and these are Weld Notes. So let's take a look at some of...
Okay. Is it clear now?
Yeah, it's clear.
Okay, great. The last thing for today would be how to measure the period of an oscillation of a simple pendulum. I think you did this with me when I was solving a paper 4. Yeah, so ওরকম টাইপের একটা question. এগুলো সবসময় আসে paper 2 তেও আসে. So it's quite simple. Okay. Okay. So I already mentioned before that what do we count as one oscillation? One oscillation is going from A to B, B to C, and then all the way back to A. Okay, that is counted as one oscillation. Yeah. And how do you measure the period T? period T means T is the time taken for one oscillation. So how do we do this? You already did this. Obviously, একটা period measure করা অনেক difficult আমাদের জন্য. It wouldn't be so accurate. Why? Because we humans actually have a reaction time, and আমরা এত তাড়াতাড়ি একটা stopwatch start and end করতে পারবো না. So it wouldn't be so accurate. So how do we actually find out the period T? Hello?
Yeah, Apu, we take an average, right?
Yeah, exactly. So we time for 10 oscillations. So time 10 oscillations. And then we take and then we divide by 10, sorry. By 10 to get period T. Okay, because it's easier for us to actually measure the time for 10 oscillations rather than one oscillation. Okay, this will be more accurate. Okay.
Yeah.
Okay, another point to note down is that yeah, what is the amplitude and the length? This is the fixed point, and the length is from here all the way to here. This is what we call an L. Okay, so the distance between the fixed point, between the rest position of the bob and okay, no, this is length L, and what is the amplitude? This is period. What is the amplitude? You know, this is simply the distance between point B and point C. So either point C or point A, the distance between them is called amplitude. So like this distance and this distance, okay, these are amplitude.
Yeah.
Okay. Now, একটা formula আছে, which you can use, which is actually easier, and that is the period T is equal to 2 pi L by G, I think. Okay, so here you can see that the period, that is the time taken for one oscillation, the period of a pendulum is actually affected by the length by the length of the pendulum, and also the acceleration, the gravitational acceleration. Okay, so this G is actually the
Apu, this is 9.81, right?
yes. Oh. And L is the length of the pendulum, যেটা আমি উপরে label করছি, okay? Okay, as you can see, T is proportional to L, T is inversely proportional to G, okay? Another thing to point out is that T is not affected by the mass of the pendulum bob. The pendulum bob is this ball, okay?
Apu, isn't like the more heavier the ball would be, wouldn't it take more time to move?
No, that's the usual thought of everyone. Like that's how we think, but actually that's not true, because the period actually only depends on the length and just the gravitational acceleration. And gravitational acceleration obviously are the shobar jonno same, which is 9.81. So you can just consider it a constant. So I'm going to actually remove this part, since g is a constant on Earth. So you can say that the period only depends on the length.
Yeah.
Okay.
So Apu, the longer the length, the longer the length of the string or whatever it is, the longer it will take for one oscillation to occur.
Yes, exactly. The longer the length, the longer the period will be. আমি এখানে root দিতে ভুলে গেছিলাম, but I just added it, okay? That's it for today. Yeah, I think we'll meet again tomorrow for biology, right? Okay. See you.
Take care. Bye.
Bye.